Hello friends, welcome to EPG Pathshala. I am Dr. Vineet Kumar from Dr. Ranganathan Institute of Library Information Science, Bundelkhand University, Jhansi. Friends, today we are going to talk on module Multimedia Information Retrieval from paper Information Storage and Retrieval. In this module, you will be able to understand the answers to the following questions. First, what is multimedia information retrieval? What is text, image, audio, and video information retrieval? What are the various approaches that are being followed for the retrieval of the above? And what are the areas of application of multimedia information retrieval? Friends, as we all know that text has been the predominant medium for communication of information. With the availability of better computing capabilities such as availability of disk space, memory space, display resolution, and better processing power, the other media such as image, audio, and video etc. are also gaining importance. There are many fields of work that require access to non-textual information. For example, medical professionals and need access to medical images, architects to building plans, ornithologists to bird calls, estate agents to property photographs, car engineers and buyers need photographs and sound of car engines, and so on. This gave rise to another kind of systems that have been developed to handle information contained in more than one medium, known as multimedia information systems. In the other sections, we are already aware that the text information retrieval has been already well established. However, multimedia information retrieval is less established. For having good understanding about the multimedia information retrieval, it is necessary to understand the basics of text retrieval, audio and music information retrieval, image and video information retrieval. In this slide, we are going to discuss the definition of multimedia information retrieval system. A multimedia information retrieval system is associated with storage, that is retaining the data for further use, indexing, marking the data with some descriptors, search to provide the facility to retrieve the stored data, and delivery of multimedia data such as images, videos, sounds, 3D graphics, or their combination. It also involves some newer forms of media such as X-rays, CT scans, electrocardiograms, etc. It includes works on, for example, extracting descriptive features from images, that is to extract features from the images like emotions, colors, and other features which we will discuss later in the image information retrieval system. What are the features of images? Then reducing high dimensional indexes into low dimensional ones. Actually, what happens when we build indexes, the size of the index, it grows because the multimedia content is of high size. The files are of high size. So the as the index is prepared, the dimension of the index grows. So some works that involve reducing the high dimensional indexes to low dimensional ones. Next is defining new similarity metrics. Similarity metrics are metrics that are based on some kind of metrics that are developed to form similarity, to measure the similarities between two images, between two videos, between two text, etc. Then next is efficient delivery of the retrieved data. That is the data which is retrieved. It should be delivered to the user in a proper format. It involves working like what could be the best way to display the results which are obtained, what could be the best way to sort, or what are the other ranking mechanisms which can be helpful for displaying or the delivery of the retrieved data. Some real life examples. You might have seen the Google's image search engine. It is a typical example of a multimedia information retrieval system. Another example can be a video on demand site that allows people to search movies by their titles is another example. So in the next slide we will see the screenshot of these real life examples. In this slide you can see it is the interface of images.google.com. Here the search term is displayed as India, and on the basis of the search term some images are retrieved from the index or the stored images, and it is being displayed to the user. Here one point which is of consideration is the various filtering options which are available. You can see that there are some filtering options available like size, color, type, time, usage rights, and other tools. So the user can sort the available results on the basis of the size of the image, on the basis of the color, on the basis of the type of image, the time when the image was taken, the other rights, usage rights, etc. So how this has become possible? Because the with the image, while storing the images, other attributes of the images are also stored, like the size of the image, what is the color, what are the colors which are present in the image, the type of image. So these filtering options are specific to be specific to image databases. For example, another example is Getty Images, which is a paid service. Getty Images also provides such kind of filters like royalty free or royalty paid kind of filters are also available in Getty Images. Another image database is Shutterstock, which is also a paid image database. This is a video on demand service. Popularly, this is one example of video on demand service, that is BBC iPlayer. Here, the videos can be searched by using a text based search. So here you can see this page is available at www.bbc.co.uk/iPlayer. Here the list of programs can be searched by the text, for example name of the program or episode number or date, etc. The channels can further the results which are obtained are further displayed or changed by using the categories such as channels, categories, guides, etc. The architecture of a multimedia information retrieval system depends on the characteristics of the multimedia data and the kind of operations to be performed on such data. Sub areas of multimedia information retrieval. Multimedia information retrieval uh, has different sub areas such as content representation and multimedia object representation. This sub area involves representing the content in different formats or what kind of objects you are choosing to represent the information. Another area that is feature extraction. This area involves extracting the features out of the multimedia objects such as images, video, audio, etc. The other area is query formulation to map high-level semantic concepts into low-level features. For example, some images are displaying high-level semantic concepts. So the query formulation will be done to, or the research are going on to perform the query formulation so that these high-level semantic concepts are turned into low-level features. Another area of multimedia information retrieval is query by example. This involves searching by providing some kind of example, not just by providing the text or something, but this area involves searching with the help of giving some example. For example, in this system, you might be aware there are some online audio retrieval system where you can sing a song, and on the basis of the your humming, similar audio is retrieved. So this is one example of query by example. Another area is relevance feedback and interactive queries. How to obtain relevance feedback from the user and developing the system to to gain interactive queries or to provide interactive queries to the system. Some other areas are like efficient feature indexing and cataloging, integrated searching and browsing, techniques of searching multimedia based on their contents. So these are all areas which are involved in multimedia information system. In short, we can say multimedia information retrieval is retrieval of text, image, video, and sound data related to the user and their ranking according to some similarity degree. The better the similarity degree, there will be more likelihood of user finding the relevant answers. Text information retrieval. Text, you might be aware, text is a document that is having subtext. It involves answering user queries based on a keyword index. You might be aware what is keyword and what is an index. You might have studied well in other sections also. It is a very well established and developed field. These days, text information retrieval is a very often and very popular service. In this system, user queries are received through a text bar and are matched with a pre-built index. The results are displayed to the user and user selects relevant documents from the available results. If dissatisfied, the user can reframe the query. You might have learned about text information retrieval in detail in other modules. Audio information retrieval. Friends, speech is the most common used medium of communication. In fact, we all learn first we learn only the speech as the medium of communication. If we talk about audio information retrieval, it has become a prominent area of research over the past years. There are some issues with audio information retrieval, such as because due to the sequential storage of audio information. Sequential means like the audio is stored in the form of sequential storage. It is not a random audio storage, which means that it is very difficult to retrieve a particular piece of audio out of a long recording. So it is very difficult to sieve out or to search a particular bit of long recorded audio. That is the most trouble issue that is involved with audio information retrieval, and that's why most of the research is going on in this area to retrieve audio information. And there is another issue that there are chances of losing the context of the retrieved audio, because if we are cutting or if we are searching for an audio, maybe that audio matches whatever we want to search, but it doesn't matter if it matches, because every whatever we speak, it is always having some kind of context, and without context maybe that information will yield a different meaning. So there are these two issues which are being handled in audio information retrieval. In this slide we are going to talk about the various methods of audio retrieval. The first method we are going to discuss is conventional method of audio retrieval. In this approach, the conventional text retrieval techniques are applied to voice retrieval. In this, good quality transcripts are created for the audio and conventional text retrieval techniques are applied on them. The advances in speech recognition have made it possible to automatically generate good quality speech transcripts. A perfect automatic speech recognition system, that is ASR, that can efficiently transcribe spoken audio document would be an ideal solution. Hidden Markov models form the backbone of ASR systems. An hidden Markov model is a statistical representation of a speech event like a word. Model parameters are trained in a large corpus of labeled speech data. Once a trained set of HMMs is generated, query speech can be matched to find the most likely model sequence, that is the recognized words. However, even good quality transcript lacks punctuation, paragraphs, and all the elements that provide structure. Although the retrieval based in speech transcript seems to be very close to text retrieval, in practice it is not so. Out of the vocabulary words such as proper nouns, there are some issues which are involved with the audio retrieval systems, that generating a good quality transcript lacks punctuations, paragraphs, and all the elements that provide structure. Although the retrieval based in speech transcript seems to be very close to text retrieval, in practice it is not so because of the losing the context of the speech. Out of vocabulary words such as proper nouns cannot be recognized by many automatic speech recognition systems. Another problem is that the whole process is very time consuming and expensive, as the audio documents usually have large sized file and it requires highly trained professionals to edit those files. Similarly, music information retrieval is also another area of research in multimedia information retrieval. Music information retrieval is very less developed field as it does not contain any specific words per se. As we all know that text retrieval uh, basically based on keywords, but here in music there is no keyword, so that there is a it is a issue, and so research are going on how to find music from a set of musics. So the transcript generation is also not possible for music information, as we learned about that for audio the transcript generation is very helpful for retrieving the audio. Any musical info, if you talk about the properties of musical information, it consists of 7 facets. We'll see some all the 7 facets. The first facet is pitch. Pitch is a quality of sound that is related to the frequency. So uh, of high frequency, the pitch will be low. Similarly, tempo, information concerning the duration of a musical event. Third facet is harmony. It is related to the attribute of music. Fourth is timbre and related to tone. And the next property is that is editing. It is related to the performance instructions as fingering, ornamentation, articulation, etc. You might have seen people doing such kind of movements, that is fingering. So this information is also involved in music information. Then next is text, that is related to the lyrics, symphonies, and so on. You For music, for songs, you might have learned what is lyrics. Lyrics is the words which are used for in the songs to display the emotions, feeling, etc. And the last facet is that is bibliography, seventh facet, and it is nothing but the information about the composer, performer, title of the piece, publisher, etc. This bibliography can help in music information retrieval, but that again it is based on text information retrieval. Query based music information retrieval. A query based music information retrieval system relies on similarity matching between the query and the stored music. The user is provided with an interface where the user submit query by playing the music or humming a tune. The received query is then transformed into digital format and matched with the digital copies of the available recordings. Or the edit distances are matched. Sometimes the pitch contours, time contours, etc. that represent the rhythm information is matched. This is one music search interface available at www.midomi.com. Here, the user can search by humming a song, or like it is written, click and sing or hum. So when you press at the lens button and you sing a song at least for 10 seconds, the interface captures the voice and search the index and brings the similar records to the user. This is called the query based music information retrieval system. Here the query is by humming. In other approaches, text-based retrieval techniques are used for music retrieval, such as providing search by the name of the artist, title of the song, file types, popularity ratings, and by keywords. Audio retrieval also faces many challenges because of two distinct qualities of audio data. First is that audio data is orally based instead of visually based, and second is audio data is time dependent. Second issue that is being faced is the presentation of the retrieved result is also a challenge. As the audio data is time dependent, a user when supplied with, say for example, 20 clips and simultaneously played would be of no use to the searcher. There are some efforts going on for finding definite and definite and concrete moves to build browse and navigate features or results that are displayed to the user from the audio databases. Now we'll see what is image information retrieval. Among the audio, video and image information retrieval is the best developed technology. Since the beginning of civilization, images are being used as a major medium for communication. In your history books, you might have seen that the our ancestors used to draw images on the walls of the caves. Since that time, the image is the major medium of communication. If we talk about the research and development in the area of image information retrieval, it has grown since 2 decades and matured. However, image processing and retrieval activities began in the 1980s and became active area of research interest since the creation of the World Wide Web in the early 1990s. Several commercial image data management systems provide retrieval based on metadata, text keywords, or assigned descriptors. These metadata and descriptors are manually provided by human indexers by describing images, the attributes of the images. The process of describing images by human indexers is very expensive and time consuming process, and yet is highly subjective. For example, for me an image can be beautiful, but for you it might not be. So the descriptors which are used by human indexers are highly subjective in nature. The attributes that describe an image or the attributes that can be used for retrieval are: first, a combination of color, texture, shape, and so on. Second, a specific arrangement of objects in the image. For example, a cow, a calf before the cow, or a cow before calf. So these kind of arrangement can also be used. For example, a tree, a hut below a tree. So these kind of arrangement can also be used for searching. Third, depiction of a particular event. How we depict the particular event. So that this depiction can also be used for searching or for indexing the images. Next is presence of one or more persons or objects. For example, this happens in the case of media searching. For example, in some event, international event, the prime minister of a country or two countries when they meet together. So if we want to search, if this description is being saved with the images, it will be very helpful uh, to retrieve such images based on presence of a person or some object. Then another attribute is presence of a specific location. For example, recently the President of America, Obama, visited India, and at several places he visited. In New Delhi also he visited and met with ministers and dignitaries of India. So if we are specifying a particular location, then this search becomes easier. Sometimes another attributes, that is emotions attached to an event or a person, can also be used as an attribute to search in information retrieval systems. There are two approaches which are followed in image retrieval. First approach is context-based image retrieval, and the second is color histogram matching. Context-based image retrieval (CBIR). Several commercial image data management systems provide retrieval based on metadata and text keyword or assigned descriptors. These metadata descriptors are manually provided by considering a combination of color, texture, shape, and so on, a specific arrangement of objects in the image, depiction of a particular event, presence of one or more persons or objects, presence of a specific location, emotion attached to an event or a person, and so on. This makes it very expensive and time consuming process. This is one example of context based image retrieval. This is the interface of TinEye that is available at www.tineye.com. Here you can see that the interface provides the facility where the user can upload an image to start the search. So this is actually the matching is done on the basis of the image which is uploaded by the user, and this interface does not provide text based searching. So this is the area, context based image retrieval, that involves how the query is done through an example which is provided by the user. If you talk about the interfaces of the CBIRs, two different types of interfaces are developed. First is browsing and navigation interface. Here the user is allowed to browse a collection and navigate through a structured collection of images in order to retrieve the desired image or images. For this, for example, an interface is provided to the user where a lot of a collection of images are available to the user, from which user selects a particular image. Another is that is query interface, whereby the user can specify an image from a collection which is used as a query to search the database. So in this, the user selects an image from the collection, and then that particular selected image is used as a query. The matching process. The matching process involves matching the similarity between a query image and the image objects in the collection. The similarity is measured, computed, and images that fully or partially match the query are retrieved. Other approaches involve answering the query based on color histogram. The color histogram shows the proportion of pixels of each color within the image. A color histogram is computed for each image in the database and stored internally as vector of values, which are easier for matching algorithms to match with the query. This approach solves queries like find all images whose most frequently used color is similar to this image. So where we want to match on the basis of the colors. Now we'll discuss about video information retrieval. Video data information retrieval shares some properties with image data retrieval due to the commonality of their visual nature. But video is a time dependent, which means it changes with the passage of time. Also, as video is associated with synchronized audio track, the image and audio retrieval techniques are applied on video retrieval too. Video retrieval systems are still in early stages of research and development. There are some popular approaches that are being followed in video retrieval. First is that is the application of text retrieval techniques combined with context-based in image retrieval techniques. As we discussed in the image retrieval, the properties of the method and the approach of context-based information retrieval. So this is the best solution which is available, that is application of text retrieval techniques combined with context-based image retrieval techniques. Second approach is indexing of video metadata, color histograms, texture analysis, video segmentation, that is breaking the video into small segment, usually where the camera shot changes, and pattern recognition. In this approach, the video metadata like who is the author, who is the camera person, and what are the properties, what is the event for which the video is. These kind of information, textual information, is indexed. That is the video metadata. Another property is that is color histograms. The color frequency based color histograms are prepared, and those histograms are further matched with other color histograms so that the video similar videos could be retrieved. Another is texture analysis. Then video segmentation, that is like I said, breaking the video into smaller segments, and then saving those segments in the form of uh, small segments, and their index, their metadata is same. And the another is that is the pattern recognition, that recognizing a similar pattern in the video so that these patterns could be again matched and the videos could be retrieved. So these two approaches are broadly followed in the case of video information retrieval systems. So this is one interface of video retrieval system. This is available at screen.yahoo.com. So here the videos can be searched by providing some text retrieval or texts. So basically this interface involves text retrieval techniques, and it gives results in the form of videos. In another approach, if closed captioning signals exist for a video, the keywords are extracted from the text of the closed captioning using well understood text manipulation techniques. Closed captioning can be understood as subtitles or the CC or closed captioning you might have seen in some videos on web. If the closed captioning does not exist, the keywords are extracted from the audio stream by using automatic speech recognition techniques. Another strategy involves use of keyframes. Keyframes are frames whose images represent a semantic unit of the stream, such as a scene. After extracting the keyframes, image retrieval techniques could be applied to support queries on keyframes. This is the screenshot which is showing the closed captioning available on almost all the videos on www.youtube.com. So here you can see closed captioning marked with the arrow. Whatever the speaker is speaking in this video, that is being automatically recognized and displayed as text. So this information can further be used or indexed for textual searching and enriching the text index of the videos. Friends, let us summarize what we tried to understand in this module. We tried to first define what is multimedia information retrieval, uh, what is text, image, audio, and video information retrieval, the other various approaches that are being followed for the retrieval of the above, and the areas of application of multimedia information retrieval. Hence, multimedia offers a richer experience than the plain text and other details which are otherwise not possible to express in text-only formats. Like, for example, feelings and emotions are well expressed in the form of images or videos. Finally, we understood the various aspects and properties of images, text, audio, music, and video information representations, the concept of multimedia information retrieval, and types of media that forms multimedia. Though the text is most prevalent formats for information, the underlying technology and developments in the infrastructure are making other forms more visible. The approaches being used for developing multimedia information retrieval systems are also discussed. Thank you.